Thanks for joining me. We're going to talk about developing with Kubernetes locally, but not just locally. First, a little bit about me. I know it's at AT&T, and I was there until a month ago, but I switched companies. It's good to refresh things every now and then. But I'm going to give some examples, and they're going to be from AT&T. And I've been around for more than 20 years, doing development, architecture, lately more of a cloud architecture and modernization, part of a large endeavor in AT&T to move many applications to the cloud. They have around 7,000 applications, and I think around 5,000 is moving to the cloud, and I was part of this endeavor, and also write some blogs, so feel free to look me up and speak at conferences when I'm invited. We're going to talk about development in a microservice environment, which is very common nowadays, and see how Kubernetes fits in. I'm going to review some options you can use, and you can later choose your own. But let's start at the beginning. I think that microservices architecture is like the common approach today, even when not needed. And it is like that for a good reason, right? I named a few reasons here. It's not a complete list, of course, but mainly the speed of development, due to the independence of a small service that allows you to develop independently and deploy and test. Everything is in a smaller scale, which speed things up considerably. And of course, the ability to scale it in production separately from other services. So there are quite a few advantages. That's why it became so popular. But you know that nothing is perfect, and running with, I don't know, 5, 10, 20 microservices is still easy to manage, but sometimes you take it too far, right? And you might end up in this spider web. Hope you can see the dots. Everything is interconnected, and it becomes really hard, not just to manage it, but also to understand what's going on. And I just know that even for a simple, even for a first microservice, you still need to have a lot of supporting services, right? The API gateway, you have to discover your services somehow. You'd have to have a central configuration, right? You don't want to pass config files through hundreds of services. Logging can be an issue when a request is bouncing through many services. So you have to have some central, elastic stack or another framework to support that. You have to administer all that, alerts, monitoring. It becomes complicated. So my advice is always to start simple. Even if you think microservices, usually you're better off starting with a monolith and break it to services at the right moment. This is particularly true for new applications, right? If you start a new application, you don't know if it's going to succeed. You don't know sometimes the exact requirements, which changes all the time. So starting simple is always, or almost always, better. During modernization at AT&T, usually it was a bit different because we already knew what the requirements are. We didn't change them much, but we redesigned the application. So sometimes we started with a microservice environment from scratch. But again, that's not always recommended when you start a totally new application. A word about different technologies. One of the advantages of microservice environment is that you can mix and match technologies, right? One service can be in Java, the other one in Go, or whatever language you prefer, and you can use the specific language for the specific need, or if these are different teams, some teams are specializing in Go, so they can use this technology, which is kind of good, but it can be dangerous. I remember a while back, one of the star developers came to the R&D manager and told him that there's a new framework in town and it's going to be the next Java killer. It was called Ruby on Rails. And we must write all our services with this framework. I think we did one service, and of course, it didn't kill Java. It committed suicide. So we had to rewrite the service from scratch after the star developer left, and we got stuck with it. So you always have different considerations, and I can't tell you what to do. You just have to know the pros and cons and decide for yourself. And the management became a little bit easier with Kubernetes, although Kubernetes itself is complicated, has some moving parts, but some of the problems were solved, others were introduced. So what will you do when you're going to have a lot of microservices, right? Again, if you only have 2, 3, 5, even 10, it's easy. But when you're a developer in a complex environment, it can be hundreds of microservices, and you want to test stuff, it becomes a little bit harder. And I'm not talking about unit tests, right? In this case, you can just run it locally, usually not dependent on any other services. So that's easy. But I'm talking about more of an integration test or a higher level testing of tracking of a business flow. And I can give an example. In AT&T, like I said, there are lots of applications, and some of them enables you, the end user, and it doesn't matter if it's a company or some consumer, to order some service or equipment, communication equipment. And it sounds rather easy, right? If I'm writing the ordering service, it should be easy, but it's not. For example, even to show the list of services and equipment that a user can see requires going to a catalog, which is another service, but that's not enough because not all services are available to this customer. It maybe depends on the contract, which is another service. It may be even depends on his location. If he doesn't have optic fiber reaching his building, for example, then he cannot use some equipment that AT&T sells. So a few services only to determine what products he can order. And pricing, it's almost never a fixed price per product, but it's always calculated. It's based on the customer, again, the contract, on sales. Sometimes you want to compete with other vendors, so you lower prices. And this has to be calculated per all of the parameters I've named. And even after you have the product and the price collected from different services, only then you can order. And if this is a service that requires installation, for example, you have to contact the technician schedule, right, in this area, and again, match it. After making the order, you have to send events about it to several other services that are interested in this information. So even placing an order requires lots of other services. And if you want to test this flow, you can either mock them, which is a problem for two reasons. A, you need to understand the business logic of these other services. And one of the reasons you're working in a microservice environment is to focus on your own service. To do it faster, you don't want to spend time studying the entire business logic of other services. And even if you do, it's going to take you time to build these mocks correctly because there are a lot of business cases you need to handle correctly. Otherwise, your integration test worth very little. So you're going to end up wanting to run against other services. And the question is how, right? You can do it in several options, and I'll review them. The easiest one, suitable for small companies, startups, is to run everything locally, right? I'll just start the 3, 5, 7 microservices in my own local machine and check everything this way. Anybody here is working this way? Okay, one. I'm curious to know what the others are doing, but we'll get to that. But in this case, it has several problems, right? You have to always keep the services up to date and building them and running them, not to mention the data, databases you have to keep up to date. And at some point, maybe on the fifth service, maybe on the 10th, depends on the services, you'll run out of resources, right? So it might be a problem. So we might run all of these services outside a local machine. We can use Kubernetes for that, right? Enter Kubernetes. It has a lot of advantages. So we might as well run everything far from us in the cloud or a public cloud, private cloud, and it can work, but there's always a but. And when you come to weigh these two options, you have, again, advantages and disadvantages everywhere. Here, you're limited by size again. And if you do it remotely, you're not limited by size, but you have to deal with other issues, for example, deployment and debugging remotely. And I'll soon give a few words about cost, right? How many here are running for developers Kubernetes clusters in the cloud, for example? Okay, a few. That's good, because as a side effect of this talk, I'm going to show you how you can save a lot of money doing so. But that's clearly a common option. Or maybe you can do some mixing and matching, right? You can have a central environment, and developer will just run some of the services, usually one service they're working on locally. But there's an issue, right, in this approach. Maybe you've already encountered it. If I'm running, let's say it's not Kubernetes, right? It's just services, Spring Boot services, running along in some central environment. And developer 1 is running service A on his machine, debugging it. So when developer 2 runs working on service B, trying to run a business flow, his service B might call service A. Now, when this service discovery is being done, these two service A's are equal, right? So some of the requests will go to the commons, to the central environment service A, and others will go to developer 1 environment, which might return different results. The older APIs might not exist on his machine because we removed them. And there might be a breakpoint that keeps developer 2 from continuing to work on service B. So mixing and matching also has its drawbacks. So we looked at 3 options, right? Running everything locally, running everything remotely, and doing some mixing and matching. So a little bit about cloud cost. Again, I'm not going to ask you for the numbers that you're paying, but you can see the trend, right? Cloud payments are skyrocketing, and this is only for 2020. I guess it's much more since then. And I can tell you that in AT&T, the monthly cost in the cloud is more than $20 million. per month, not just for developer Kubernetes clusters, of course, for everything, but they're only half the way from in modernization and migrating to the cloud, so it's going to be much higher. Though they got an excellent deal from Azure and they're working on cost optimization all the time, still very costly. And the result, I don't know if you can see the number, the revenue was like 80 billion for Amazon in 2022. I guess it was more in 2023. It's going to be more. And thank you. You're running your clusters in the cloud, many of you in AWS, so you're valued contributors for this number. So it might be a problem, right? Again, if you have 5 environments, less of a problem. If you're successful and growing in size, it's going to be a problem at some point. So if you're not doing this already, and I know many companies are doing it, but not all of them, keep a very strict look at your cost, right? It might run wild. And you have various tools to track it. And this is not a talk about managing cloud costs, but I can just tell you again from AT&T that the non-production environment were usually more costly than the production one, right? Environments were never shut off outside the working hours. Data was not cleaned in databases and files, and everything is accumulating. And once you have a lot of applications, again, it turns to be very expensive. So keep an eye on that, but that's like a side note. I promise you that you can save some money. Again, this is like a side note from running Kubernetes locally. And I'm not talking about that. I'm saying that you all have free clouds in your companies. What do I mean? AT&T again, they have more than 250,000 of employees, right? And each one has at least one laptop or desktop. And these laptops and desktops are usually idle, right? Off working hours, during lunch, during meetings, even now, right? I'm presenting this presentation and my i7 is not even breaking a sweat. So why not use these machines to run workloads, right? For free. And the bigger company you have more workloads and you have more servers at your disposal. Anyone here is as old as me and remember SETI? Oh, quite a few. For those who are not, I think the initials are search for extraterrestrial intelligence, right? Looking for aliens, in other words. It was a NASA project back in the 90s, the beginning of the internet. People were more naive then, and they downloaded an exe file to run on their own home machine when it's idle. And it used to do some calculations that allegedly were going to help NASA to find aliens or mine Bitcoin. I don't know. No, it was a little bit before that. And millions did that, right? Millions of people downloaded this application and donated their computing power for NASA. So it's not a new idea, right? And nowadays the tools and knowledge about distributed computing is far more developed than it used to be back then. So it's easier. And you can use either Kubernetes, meaning your employee's machine can be a node in a Kubernetes cluster, or you can even use browsers. I have a talk about that, since browsers can be full servers. Think about it. Every tab is isolated. It's like a container. It has a lot of web APIs you can use to do computation. You can even run machine learning models with TensorFlow on a browser. So it can be very easy to use that. No installation, simple management. But as you can suspect, AT&T is a big enterprise, very conservative. It was a bit too innovative for AT&T, but feel free to use this idea. It's definitely possible. I did that as an experiment in both ways, either Kubernetes or through browsers. So it's definitely possible and free. But again, that's a bit to the side. Not all organizations are open to different kind of thinking like this. So we go back to our main path and talking about running Kubernetes locally. So let's focus on that. When the options are running your services locally without Kubernetes or with, some advantages. It has the same topology as production. You can, this is important because otherwise you'll discover problems maybe too late or later than possible. And it's always better to find them early in development. The cost is minimal this way. So it's much more similar, same images, same possibly YAML files you use in production. Of course, different secrets, different configuration, but everything else is similar. So it has a lot of advantages, a lot of tools for Kubernetes these days. To monitor, to alert, to deploy, you can have simple dashboards for free to see how everything is doing. And again, it's cheaper, right? Because using your own existing machine. Again, remember, you can do it up to a certain size, but sometimes, or in many cases, you can do that, or even narrow the environment to minimal number of services. So it's a common option. More advantages, right? When your developers are aware of the production environment, it helps them to find issues in production sooner or notice differences in the environment that might cause issues sooner, right? It related to the phrase of you build it, you run it, or the shifting left movement, which I'm a little bit ambivalent about it, because on one hand, owning everything by developers can help, like it says here, but the amount of time that is free for development, actual code writing is narrowing down. Maybe it's not an issue with ChatGPT and Copilot anymore, but sometimes it's asking too much from developers. So again, it depends on your company, depends on the people, whether you want to go this way or not, but it helps to know how things run in production. You don't have to deploy to a remote cluster. A lot of hands were risen here when I asked about using remote cloud cluster. It's faster this way. And you're not dependent on the network. I don't know if that's an issue for you, but sometimes remote clusters are not available, and here you are self-contained. You can work at home, you can work offline. So that's an advantage too. So consider that. But again, two sides for everything. It's still complicated, right? What happens if you have an issue running your own local cluster on your machine, right? Who handles that? So you either ask for the developers to be Kubernetes experts too, or you need someone to support that. And again, sometimes it's an overkill. If you have 1-2 services, why run another heavy environment and manage that? And I know it was in the pros as well, but sometimes you can't mimic the production environment accurately. So you'll end up having a complicated Kubernetes cluster on your own machine, and it's going to be different from the one in production. So think about that as well. And we might want a lot of stuff from a Kubernetes cluster, right? When you come to choose, I'll talk about the various options you have to run Kubernetes locally. And this is like a complete list. You can, or you should, choose your own subset of features you'd like to have in your own Kubernetes environment. Maybe certificates are not an issue, and maybe you just need one node. The implementation are different, but it's definitely a list to consider when you're coming to choose your local Kubernetes implementation. And so far, we talked about these few options, right? You can run everything locally. You can run everything remotely, including your IDE. You can use Cloud9, for example. Or you can like mix and match. And the difference is that in one of them, you use local host and just connect to a remote cluster, and in another option, you deploy everything to the cluster and test everything there, but develop locally. So you have tons of options. More consideration. Developer experience. You know that it's a topic well discussed, and you should think about it here as well. Will this Kubernetes environment is easy enough for developers, easy enough to admin, because you're going to need to support it at some point, and how realistic this environment is. Maybe one node implementation is enough for you, maybe it isn't. So let's talk about some concrete implementations. First of all, Kind, which is fairly easy to install. I'll show that to you in a second. And it supports many multi-node implementation, and each node is running in a container. So you have to have Docker installed. And I like it simple enough. It's a bit slow compared to other implementations. Minikube is very common. Not sure if it was the first or not, but it's coming from Kubernetes. Supports many features, open source, but again, a single node implementation. Sometimes that's enough. You can run multiple pods on that single node. K3S and K3D is coming from Rancher Labs, who's making a lot of cluster management software. And it's, I think, the most lightweight of them all. So if you're using IoT or resources is an issue, you can consider using that as well. And you can run it inside Docker to simplify stuff. And last one from the guys in Canonical, they have yet another implementation. These are just like few implementations. There are going to be more all the time. So keep track on that and find whatever suitable for you. Another like comparison in this form. You can see that they have some differences in the required memory. So that's a consideration if you want to run it locally on weaker machines. And again, it depends if you want to run multiple clusters or nodes and do some load balancing inside. So you have to consider all that. Now, the interesting part is that you have lots of add-ons and tools and frameworks you can use to make your life easier. This is, again, just a partial list. You're going to have the presentation available later. I'm going to talk about two and demonstrate one. Jafara is a tool that enables you to be connected to a remote cluster, right? In case you don't want to run everything on your machine to go hybrid. And it takes your local containers and using a tunnel, connects them to a remote cluster. Then you can consume other services and communicate with other pods. So all you have to do is deploy your stuff into the local container, and then you can remotely debug it. But you might still have the collision problem that I've discussed earlier. But it's a nice product. And even more interesting for me, and I got to say that I have no relation to these two companies, though I like telepresence better. It takes a different approach. It allows you to debug locally without the local container by intercepting the traffic inside the Kubernetes cluster and redirects it back to you, right? Which is an interesting idea, letting you debug one of the services running inside Kubernetes and just get all its traffic and debug as if everything is running locally. It's very nice. And it actually solves the collision problem. They basically have two modes of operation. The global interception, meaning I'm a developer debugging service A. I'm asking telepresence to intercept all traffic going to service A and redirect it to me using a browser or API calls, whatever I like, which is good. But again, if I'm having other developers here, I'm having the same problem. That's why they have a different option, what they call a personal interception, telling telepresence, redirect some of the traffic for service A back to me. And in this case, just request that I've initiated, right? So if I'm testing something and initiating a request that's going to this cluster, and one of the calls is going back, obviously, to service A, it will go back to me so I can debug it. Developer 2 running another testing flow to this cluster and calling service A will reach this service A without interrupting anybody else. So it's great. I must tell you that this option is only in the paid version of telepresence, but since in this way, maybe you can reduce the number of remote cluster you're having, right? Not one per developer, but one per team, or even one for the entire company, depends on the size. It might be worth paying for that. And noting that the basic version of telepresence is open source, so should be not too hard adding a condition to the interception and telling it, don't redirect it automatically as you do now, but only if a certain header is present, or in some other condition that allows you to mimic this behavior of personal interception. Again, shouldn't be too hard, especially if you know Go. So this actually can solve the collision problem and reduce the number of remote cluster, enable you to do more locally. Some guidelines which are, again, common when deploying to production, be as similar as you can. Don't run away from the production environment, because you're going to have hard time finding issues later. Don't ever hard code properties, always get them from outside, from some secret manager or some external source. It would be easier to switch between environments. Don't forget the databases that need to be updated and similar to production as well. Don't touch anything manually, because you'll forget to do it in other environments as well. And always promote as fast as you can, right? To keep the main goal of being similar to production and see how things work as fast as possible. So let's take a look. Since starting a kind cluster takes, I don't know, 2 to 3 minutes, already started one. So we can see that I've started a cluster of 3, I hope you can see that, 3 workers and 1 contour plane with several ports that are open. And I've created an application with several tiers, YAMLs that are common YAML standard ones. And this is how it looks like. I have a web deployment and a service, application and a service. The details here are it doesn't matter. It has 3-tier application. And everything functions as a regular Kubernetes cluster. You can see the 3 last rows are the one that matters here in this example. And if we take a look at the pods, see they have 3 webs, which I requested here. So everything functions exactly as a cloud, or let's say a full-scale Kubernetes cluster. And at the end, we get this chat application with a database behind that I run locally and I can play with. That's simple enough. And the other stuff you can do is using telepresence. I've installed telepresence and asked it to intercept my cluster. So if I want to debug this specific service, I can start a debugger. This service just multiply the number, and it runs on port. Not sure if you can see, but it's 31557. But when I work against it, I work with 31556, which is the which is the Kubernetes port. So I work against the cluster, and I'm hoping that requests will be redirected to my my machine. Let's refresh that. And it does. I get the request I want, which is nice. But not only that, I can change. I don't want to multiply that 5 times. I'll multiply that 3 times. And when I do another request, traffic is rerouted to me. And the result, hopefully we multiply it 3 times. And yes, I get the new number. Again, I'm not working locally. I'm sending the request to my cluster. It can be remote, of course. And this traffic, which I requested it here, is sent to this port. So I can debug it easily without having to redeploy or building a new image from my code, which is much faster this way. And remember that it enables you to run one cluster, and the rest of the team can work with you without interrupting each other if you go for the personal interception. So you have various options, and you have to decide for yourself. Sorry about that, but you have to consider, again, a type of people and the stuff they know and they're willing to do, amount of resources you have, size of your application, 5 microservices, 50 microservices, and make sure everything matches, and just don't forget the option to run everything on developers' machine and save a lot of money. Thank you for listening. Any questions? Yes. Sorry, can you speak a little bit louder? Well, the traffic, actually, the hot code is local, right? I'm not changing the deployment or the code inside the pods, but since the relevant traffic is directed to me, I can debug it. And I don't know about you, but for me, it never works the first time for me. I have to change it once, twice, 3 times until I get the logic right, if it's not a simple one as this. So only when everything works locally do I have to deploy it, and it saves lots of time. And when I'm deploying it, I can still use Jafara, like as I showed you before, and having the container run locally and not have to deploy everything to the actual cluster and cause some restart and replacements of pods, which takes more time and might interrupt other people in the team as well. No more questions? Great. So thank you again.